Is there a rule that, that allow me to do that? I haven't taught you a rule that allow me to do that. You can look back. No. Let me remind you. Let me ask you another question. Is a plus b quantity squared is equal to a squared plus b squared? No, right? No, I hope no, not you guys. This one you have to write out twice if you FOIL it. You're gonna have like at least 3 terms, right? This one is so there's no rule if it's subtraction or addition. There is no rule that allow you to distribute the power into one of those terms. Same thing here. Same thing here. There's no rule that I'm allowed to distribute the negative one into one of the. I know it tempted, like, oh, it's so nice. X to the first plus y to the first done. Right? I hope that was easy. So the only time you're allowed to distribute the power is when they multiply or divide. Okay? So please don't do that. No, don't do that. Okay. So be not equal here. So what I'm going to do first is there's many ways of doing this. What I'm going to do first, I'm going to take care of the power outside. I don't like negative exponent. So let me recall, if I have a to the negative 1 is equal to 1 over a to the 1, then what do I do with this? What should I do? I just flip it, right? I just flip it. So it's gonna be 1 over x to the negative 1 plus y to the negative 1 to the first power. Because this whole thing right here is over 1. Yes.
Why would it still be x to the negative 1?
I only take care of the outside. I haven't done anything inside. Oh, so one step at a time. Now, usually we don't write like this, do we? We just kind of ignore the 1 outside, right? Next, I'm going to take care of the 1 inside the parentheses. Erase that. So keep the numerator. For the denominator, x to the negative 1, you can rewrite it as 1. 1 over x, right? 1 over x. 1 over x. Same thing with y to the negative 1, 1 over y. And then to the first power, but we don't really write those. Complex fractions, you guys remember? Complex fraction. If I was you, I'd do this. For the numerator, I can write it 1 over 1. Is that okay? What is my LCD for all 3 of the meaty denominators? What's my LCD? What is my least common denominator for all 3 of the little mini denominators? I have 1 over 1, I have 1 over x, I have 1 over y. What's the LCD? XY, right? XY. I'm going to use the ultimate LCD method. So what I'm going to do is I'm going to multiply, I'll use blue, xy over 1. And then in the bottom, I do the same xy over 1. So that xy divided by xy is 1. I did not change. Well, xy over 1 times 1 over 1 is still xy over 1, well, just xy. In the denominator, if you distribute that blue xy into one of the term, what do you have? Yeah, xy over x, which is y. And then xy over y, which is x. And you're done. You can write it at what, x plus y, does it matter? Now, some other, yes, go ahead.
So you want to distribute like the bottom,
Oh, you say why don't we do that?
Yeah, why is that?
So that we don't change our expression. If say hypothetically I just do it like that at the bottom, then you actually change my expression. Right? The reason I'm put if I multiply the bottom to something, I'm supposed to do the same thing to the top. So
Yeah.
over one.
So, but why is the xy on like the top of the bracket? If we're trying to get like the same denominator to add the.
So LCD is of all these three is XY, right? So I need to get rid of these two guys. So I'm gonna multiply the denominator by XY over one. Then I have to do the same thing to the top. XY over one. I cannot do one over XY, it'll be different.
I'm just so confused on why the xy is on the top.
So
Like,
don't write this down, everybody.
Not on the top, like not on the top by the 1 times the xy. Yeah, not there. I'm talking about
You want
the
like that?
actual fraction stuff.
You want it like that?
Yeah.
Then it'll be different. Don't write this down. 1 over xy divided by xy over 1. Is this equal 1? No, right? Let's do this. Let's do by division. 1 over xy divided by xy over 1. Flip multiply. Sorry, I'm right by y here. 1 over xy times 1 over xy, which is 1 over x squared y squared, which is not what we want, right? We want to multiply by 1 so we don't change anything. At the same time, we'll be able to simplify. I'll give you an example. How about it's a little too abstract, maybe too abstract for you. I'll give you an example. I'll give you an example. Maybe you see this. Let me put this back before I forget, and then I'll update. You guys don't have to write this down if you don't want to. This is 1 over 2 plus 1 over 3. Tell me what's the LCD for this one? For all three. I'm doing ultimate LCD. So 1, 2, 3, what's the LCD? 6. Yeah, 6. So what I'm going to do is I'm going to multiply the bottom by 6 over 1, right? So far so good. Maybe I'll use red so that I multiply the bottom by 6 over 1. I have to do the same thing to the top. If I don't, then I accidentally change my expression, right? So right, and then you say this one is divide each other. They just 1, so I never change anything. Same equation. You don't have to do what I do if you don't like this. I know that you guys sometimes you don't like this method. Remember how many method I show you how to do for the complex fraction? 2, right? 2. Let me go back. Let me was it 1.4? Yeah, 1.4. You can either do by division, right? Do by division. So like this one, right? You take care of the top, you take care of the bottom, and then you divide it at the end, right? Or you can do the ultimate LCD. Right? For me, I like this because it's fast and it's, but maybe most students like this method. Okay. All right, you try number 2. You gotta try number 2. I'll walk around, see how you do. question, please ask.
So if I was you, I'll start with one thing at a time. It's not the denominator. So start with this first. So 2 to the 0 is anything to the power of 0 is 1. So 1 plus 1 is 2 to the negative, and then just leave it 2 to the negative 2. So that until 2 to the negative 1. Okay. And now you take care of that. Okay, so I yes, we distribute 2 in here. Right? Divide that 2 to the 4. And then you can use another rule, the product rule, to add the powers. Yes, you can, if you have the laptop with you, I suggest you have rules in front of you. But these problems, you don't know the rules, you can't do it. Do the denominator first, that's the easiest one. It's nothing wrong with fraction. There's many ways of doing this. There's no one way. Maybe I'll show you both.
I'll show you the one you're supposed to know first. Okay. The one that we've been doing using the exponential rule. Okay, so for me, the easy part is the denominator. 2 to the 0 is 1, right? Anything to the 0 power is 1. So 1 plus 1 to the negative 1 outside. And then I have 2 to the negative 1. Now, I'm going to leave it like this. The reason being is that because I see base 2, and base 2, all base 2. So I can simplify easier later. But it takes practice, okay? Naturally, people turn it into a fraction. I'll show you the fraction way as well. So other people do like this, 1/2, right? Don't matter. I'll show you both. For the top, I'm gonna try to take care of that one. So 2 to the negative 1, and then the power outside. Rule number 3, right? Power rule. So m times n. So that means -1 times 2. So 2 to the negative 2. And rewrite the front one, 2 to the negative 4. If you have 2 base, what do? 2 same bases. You add the exponents, the very first rule, right? So 2 to the negative 6. I don't like negative exponents. I need to move either 2 to the negative 1 to the top, or 2 to the negative 6 to the bottom. Do you guys remember the rule that when you flip, what do? You change the size of the power, right? So I'm going to move this one to the denominator. Right. So 2 to the negative 1, rewrite it. Then when you flip, you change the size of the exponent. This is the one here. Maybe I'll do one more step for you. Here. I'll do like this. 2 to the negative 6. over 1 times 1 over 2 to the negative. Is that okay? Can I write like that? Yeah. And then equal. So 1 over 2 to the 6th, and rewrite the second one. Still 1 over 2 to the negative 1, which is equal 2 to the what? 2 to the 5th, right? 2 to the 5th. Then you plug in your calculator. 2 to the 5th is 32. I'll show you. Alternatively, you can do the same thing using fraction. What's your name again? Angela. Yeah, Angela did that. So from this step, get rid of that thing. Let me move it to the left a little bit so I have room. Okay, Angela did this. So from this step, he changed it into fraction. So 2 to the negative 1 become 1/2. And then on the top, 2 to the negative 4 is 1 over 16. Correct? Yeah. Did you guys know why 1 over 16? Is that okay? I'll do slowly. Angela did it one step, but I'll do it slowly. 2 to the 4 times 1 over 2 to the 2. That's what you did, right? In your head. 1 over 2 to the 4 is 1 over 16. 1 over 2 squared, 1 over 4 over 1 over 2. And then you do the ultimate LCD thing. Yeah. So what is the LCD? 16, 4, and 2. So 16, right? 16 over 1, 16 over 1. Well, actually, no, I don't have to do that. I don't have to do that. Because the multiplication, I can multiply across. I'm sorry, I don't have to do that. 116 times 1 4 is what? 4 times 6 is 24. 4 times 1 plus 2 is 64. And 1/2. And then 1 over 64 times 2 over 1, which is 1 over 32. So eventually you got the same answer. I don't know which one you want. On the exam, I'll give you both same credit if you do correctly. I don't really mind. But I really want you to practice the power rule, okay? Because it's getting busier. You don't want to turn into fraction. Anyone have a question on number 2? Please ask. Please don't be shy. Okay, number 3. Again, I keep saying that there's no one way of doing these. Eventually, you get the same answer if you do correctly. But I'm gonna show you the way that I think is best for you, because I thought it was best for me. But if you have a different way, go for it, as long as it's correct. So this one I have 2 pairs of parentheses. Now within these parentheses, I don't see anything that I can simplify. Do not combine like base first. Why? Because you have the power, the power here and the power here in like going between your waves, right? Do not combine the power of the bases first. What I'm going to do is I'm going to use the power rule, distribute this into each of these, save it here, and then I combine like bases. Okay, so let's do that. So what rule is that allow me to do that? Do you guys remember? Rule number 4. Rule number 4, right? A times B to the n. All you do is you distribute the n into those factors. So same thing here. I do the same thing. X squared cube, and then y cube, which is x to the 6th, y to the 9th, And I do the same thing to the -2, x to the 5th to the -2, y to the 1st to the -2 is y to the -2. X to the -10, y to the -2. Okay, your job to finish this for me. You should be able to. In my recording, yes, I do. You have to do this one. That's the very first rule, right? You like basis? Yes, exponents. Someone give me the answer, please. Or the next step. Very good. Very good. Am I done? On the exam, I would say, how would I say that? I don't want negative exponents. So what would you do? Yeah, you just flip it. So y over 7 over x to the 4. Anyone have a question? One, number 3. Oh, the product rule, the very first one. Yeah. If you have the same basis, you add the exponent. While you're doing your homework, I suggest you have the rules up. Yes. Yeah, you flip it. Yeah. Yeah. You can flip the other way around. Say you can flip it other way. You see on example 4. Don't write this down. If I have say I have 2 over x to the -3, you can flip it the other way around. Yeah, so be 2. No, don't flip the 2. Okay, the 2 is all by itself. 2x cubed over 1, which is 2x cubed. All right. For 4. Now, naturally, students do this. A lot of times they distribute the 2 into each of these, into each of these. Nothing wrong with that. It's fine. But I don't like big number, big exponents. For me, I do this. If I can see something that I can clean up, inside the parentheses first before I square it, I would. So let's clean this up first. A squared, a cubed. What do you have? So let's clean up first before I square it. A squared divided by a cubed. So I have 1a left at the bottom, right? What about b to the -1 and b to the -2? What would you do? You can do it in scrap. Yes, you can flip, right? So let's do scrap. I have b to the -1 over b to the -2. I'm gonna move because the 2 is bigger than the 1. I'm gonna move this to the top. So rewrite b to the -1 times b to the b squared over 1 now, right? 1 now. What's b to the -1 times b squared? First rule, same basis, you add exponents. So yeah, just b. Right? Just b. So b on the top. On the top. Because these over 1 over 1. Well, CQ is CQ, nothing I can do. Now you distribute the 2. Now you distribute the 2. Right. B squared c to the 6 When you distribute, you multiply a squared. You want me to show you another way of doing this? Okay, I'll show you another way, just for the sake of your homework. I'm going to, for a lot of students do this, they distribute the two first into each of these. Power rule, right? That's rule number 7 or number 5, doesn't matter. Number 5, right? So a squared will be a to the 4. B to the negative 1 square will be b to the negative 2. Negative 1 times 2 is negative 2. C cubed square is c to the 6. And then a cubed square is a to the 6. B to the negative 4. Now you simplify. A to the 4, a to the 6 is a squared in the bottom. B to the negative 2 and b to the negative 4. You're going to bring this one up here. The power side chain becomes positive 4 plus negative 2 is positive 2, so b squared. C to the 6. Same thing, right? Same thing. Yay, we done 1.5. It's short, but it's important because you see it again and again. It's kind of like factor stuff. All right, let's start with 2.2. Sorry, 2.1. Cartesian coordinate system. You've seen this before, at least in high school. The XY axis. The person who discovered this is a French mathematician called René Descartes. It might be pronounced differently in French. You see his birthday and death day. Still not live long. I'll tell you why later. So the story is this. René, is it René or René? I have no idea. Anyway, he's a person who likes to wake up late. He stay in bed till late. One morning, he just stayed in the ceiling. I think around 11 a.m. He just started waking up, and then he saw a fly on the ceiling, and he thinks to himself, "What is the best way to describe the location of the fly in 2 dimensions?" So he, after a while, he thought of the XY coordinate that we know today. Of course, he didn't call it XY coordinate. Probably called something else. So yeah, that's how we come up with the Cartesian coordinate that we learned today. You might have seen his famous quote, "I think, therefore I am." Have you guys heard of that? Maybe in philosophy class or whatnot. I think, therefore I am. I like that quote. So the reason he died early is this. In 1649, he was persuaded to go over Sweden to tutor the Queen, Christina. And the tutoring session picked early in the morning, 5 a.m. in the morning. And on top of that, she liked to open her window while the tutoring session is going on. And you know, in Sweden, those Scandinavian winds could be very cold, right? So he endured about a few months. After that, he caught pneumonia and he died. Right? So it is sad, right? He could have distributed so much more for mathematics if it wasn't her, disrupting his sleeping habit. But some people are just like that. It's just biology. They just need a lot of sleep. Some people just sleep so little. I guess I think depend on how deep you sleep. You can sleep very deep for 4 hours and you're good, or you can sleep like straight like 10 hours, but then you wake up in the between. Does it make sense? I did that. I wake up in the between, so I sleep longer than my husband. He sleep at 4 hours, he done, it's good. But when he sleep deep. For me, I just keep waking up. I guess it's just part of the being mother. But yeah, so depend how good you sleep. Anyway, so the Cartesian coordinate system, we denote the order pair x, y. Sometimes we put a little capital letter in front of it. Instead of writing x, y coordinate, we just write the capital letters there for short. The x is called the x coordinate, and then I'm sorry, the x-axis and the y-axis, and in here, in the intersection between the two axes is the origin. So why don't you guys try to locate these points for me? Should be easy. I expect everybody here to do this. Black and white first, and then the X second. For me, I think of X is your width and Y is your height. Okay. So for example, point A, I go, so the width will be 3, right? And the height is 2. So go horizontal 3, and then go up 2. So right here, that's A. For B, -2, 5. Negatives go left, -2, go up 5. So that's B. Make it bigger. And then for C, 0, 4, there's no width, but it's been stretched to 4. So no width means it's just right out. No width, so then go up 4. So you say the origin, and you've been stretched to 4. So that's C. For D, -7, 0. The width is -7, but then there's no height. It's been stretched out to the x-axis. So you stay right where you are. Quadrants. So of course, because the intersection between the two axes, you have 4 quadrants. You're gonna count it counterclockwise. 1, 2, 3, 4. I remember the acronym. I don't understand why they say all students take calculus to remember the size of the quadrant. I don't know why. I wasn't grown up here, but I heard students use that to remember the size. If it help you and you figured out what is it related to the size, let me know. Does anyone know all students take calculus? I don't know how to relate it to the size, no idea. Maybe I'll look it up. Okay, so for the XY coordinate, the simplest example in application, so this class is application, business application. They use this to describe the linear model, the appreciation or the depreciation. Say, if the depreciation, like you buy a car or a laptop, like technology is usually the decrease value in terms. Say for example, you start out college, got into a good college, your parents grant you money to get you a good car, $27,600. So that's time is 0. That's when you start buying. The moment you drive out of the parking lot, say it takes you 4 years to complete college. How much car worth now? Roughly what, 17,000? And then after college, maybe take a job, maybe more years. So say year is now 5, 6, 7. Where am I? Roughly like 11,000. So after 7 years, your car is now worth $11,000, roughly. So for me, buying a car is like your best investment and your worst investment. Well, the worst investment because decrease in value till is nothing, right? Why is it its best investment? Yeah, you go to work, right? You be able to travel. Imagine that you take the bus to work, right? So yeah, it could be the best, it could be the worst. All right, so for me, I ski in the winter. So when I look at the line doing like this, I think it's slow. It's slow. How do I calculate slope? In high school, what do they taught you? What did they teach you? Slope equal rise over run, right? I hear people say all the time, especially freshmen, rise over run. So for example, I'll pick rise. I'll pick this point. I'll just pick a random point, okay? As long as it's on the line, right there. So maybe I'll move it to the left slightly bit. So rise is what? Rise is what? How much is from here to here? Just roughly eyeball it. Tell me what the height is. Yeah, 15. Just say 15. Okay, let's say 15. Say 15,000. What about the rise? Five or -5? Is it decreasing or increasing? Yeah, -5, right? Yeah, I know it looked like it's 5. Distance is 5, but because we're talking about slope, so if you go west, you go left, you say -5. So it's hypothetically, if you say 5, then you want to look at your graph. If it's decreasing graph, your slope should be negative. If it's increasing, it will be positive. So the slope is rise over run, which is 15,000 over 5, -5, I'm sorry. And then you simplify it to be what? -3,000. So every year you lose $3,000. For this class, I rarely ask you to do the rise over run thing, but if you want, you can. Okay, I'm not gonna stop you. For me, I use the formula. It's the difference of y over the difference of x. Have anybody Greek here? Greek? No. If you ever travel to Greek, it's pretty cool. All the signs in mathematical notation. Okay, so for example, D means delta. Right? So instead of say D, they use delta, right? Instead of PH, they use P. It's pretty cool, right? So delta y over delta x is the difference of y over difference of x. So y2 minus y1, x2 minus s1. Let me ask you a question. Using this formula, can you tell me what is the slope of a horizontal line? Or just use your common sense. What is the slope of the horizontal line? Flat land. 0, right? It's like cross country skiing right there, 0. What is the slope of vertical line? If you don't know, that's fine. It's natural. So, but let's do this. Let's do the horizontal one first. So I have -2, 6 in this point. I'm gonna plug in some numbers, see what happened. -2. Oh, not 6, 5. Right, 5. Sorry, the height is 5. And over here is 3, 5. I want you to calculate that slope for me. L2. Yeah, x1, y1, x2, y2. So y2 minus y1. Y2 is 5. Y1 is also 5. X2 is 3. X1 is -2. Well, the point is that the top is 0 over 5. So 0, right? So for horizontal line, slope is 0, according to the formula. What about the vertical line? Very good, right? Because why is it undefined?
For example, 5 minus 5 on the top, 0 divided by 0, but if you have like 5 minus 5 on the bottom,
Mm-hmm.
divide this by 0.
Yeah, very good, right? Because it's gonna change here. So for example, if I give you a point, let me give you a point. I'm saying eyeballing here, say 2 here, say 2 here, and then 3 over here. I'll say 6. Okay, so x1, x2 will be what? 2, 3, and then x2 will be 2, 6. Find the slope. X2, oh, I'm sorry, Y2 is 6. Y1 is 3. And then X2, X1 is the same. It's both 2. The thing here is you have 0 in the denominator. So it's undefined. Yeah, I don't think anybody, I don't know, crazy enough to ski on the very, very steep slope. I don't think I wanted to. I think someone would do that. Very, they like dangerous stuff. Okay, so when I ask you to sketch a line, how many points, at least how many points do you need? 2, right? For this problem, I give you 1. You have to find another one. So I give you -2, 5. Let's plot that down first. -2, 5. Right here. And then I don't give you another point, but I give you a slope. So what is that? What does that tell you? Yeah, now 4/3. That's all. So from that red point, don't start from the origin. From that red point, you go down. Rise down 4. I'm trying to down 4 and run over 3. So right there. Now you connect the 2. Oh, -2, 5. So sorry. Does anyone have a question up to this point? Is it better than 1.5? Yes. Yes. This is thing that you already know. Let me show you something. Have you guys heard of decimals.com? Anyone? Yeah, decimals. Yeah, it's pretty cool. Pretty cool website. One of my favorite. So say I'm gonna give you a few equations. Say 2x plus 1. Can someone give me another one with the same slope but different y-intercept? Sure, 2x minus 5. What by eyeballing, what do you see about the two lines? Yeah, they're parallel, right? Parallel. So let's do one more. Let's do one more. Y equal 2x plus say pi. Same thing, right? As long as your slope is the same, doesn't matter what your y-intercept is. As long as your slope is the same, all the lines are parallel, right? Let's do this. Now I'm going to change the slope into opposite reciprocal. Can someone tell me, give me a number, the opposite reciprocal to this one? Yep. So -1/2, so -0.5. If you eyeballing it, what happens to the two lines? Yeah, perpendicular, meaning they intersect the angle of 90 degrees, right? And does anyone know what they call perpendicular in 3D? Orthogonal. Orthogonal. You know when you just learn trick, just for Google.
How's it spelled?
Orthogonal. You must know. Orthogonal. That's for 3D, for being perpendicular. But they don't call perpendicular in 3D. But of course, student does because we don't care. All right. So if two lines are parallel, if and only if the slope are equal. The statement if and only if in mathematics means it goes both ways. If you are parallel, then your slope must be the same, right? If your slope are the same, then you are must be parallel, right? They go both ways. In mathematics, we sometimes notation wise, you might see this. If you see me do something like that, that means I can go up, down, go sideways, right? Go both ways. I can go back and forth, up and down. Like solving the equation, I would do that. Let's check if these two lines are parallel or not. Why don't you guys try to check if they are parallels? Yeah. I think that's correct. So M1, I do like this, so I don't, and then on top of that, I also label my point so that I don't make mistake. So Y2 is 3, Y1 is 9, X2 is 1, X2 is 1, X1 is -2, 3 minus 9, -6, 1 minus -2, that's +3, -2. M2, the same thing. So -4 for Y1. y2, I'm sorry, y2 is -4, y1 is 10. That's what, x2 is 3, x1 is -4, -14/7. So same. Oh no, I don't want to write. So m1 equal m2. So that means they're parallels. Sometimes I do. It's just like that. I'm lazy. I don't want to write it out. By the way, I post the notes on Moodle. If you miss something, you can always go back. All right. So as I showed you earlier, if the slope are opposite reciprocal, then they are perpendicular. Again, if and only if, same thing. If and only if statement here. Now, you can check. There's another way to check if they are perpendicular. Can someone give me a number the opposite reciprocal to 3? Sorry, negative reciprocal. So -1/3, right? Which if you multiply them together, what do you have? Which is -1. What about negative reciprocal for 2/5? Yeah, -5/2, which is -1. So the product of the two slopes that the product of the product of the two slope of the two perpendicular lines is always equal -1. Right? So you can always check that way as well. So this one, the slope of m1 is, let's check. X, I gotta do this, otherwise I'll make mistake. I know I will. So y2 is 5, y1 is 1, x2 is 6, x1 is -2. 4/8 is 1/2. And then m2 is given is 2. So are they perpendicular? Are they perpendicular? They reciprocal, but are they opposite? No, right? They're the same size. So they're the reciprocal. So we call this neither. I'm sorry, say not perpendicular, because it's just, let's do consistent with the question. They're just asking for whether it's perpendicular or not. Because they are reciprocal. You can say they are flipped. You want to say shorter. But not opposite. So neither. They're not even parallel. Take a minute to do this. I'm giving you one more here. By the way, today I'm staying here for my office hours. I don't feel like walking back to my office because I have to walk back here. Number 1, perpendicular, parallel, or neither. Number 2, good. Number 3, number 4, Very good. Yay, we are finished 2.1. Let's start 2.2 because that's what I did in the class. Yeah, I think I did up to number 1 and then we stop it right there. So let's do the same thing they did. Can someone give me a slope-intercept formula? Slope-intercept form. You guys learned this before. Y equal, yeah, mx plus b. By the way, we talk about lines here. It's not like square or cube. The reason it's called intercept, slope intercept, because the point slope form is deriving from the slope formula. So say if I multiply both sides by x subscript 2 minus x1, x2 minus x1. A lot of times you see me write over 1 like this. I have a habit of doing that. Now you can simplify, right? This one with this one. So I have y2 minus y1 equal m times x2 minus x1. So far, so good. And better yet, you can just drop the subscript 2. Keep the subscript 1. So y minus y1 equal m times x minus x1. That one you need to remember. See that I put if and only if. That means I can go back. Well, I mean, I should do it here. I can go back from here up to this one. Okay. Can someone tell me what is the equation of a vertical line? If you doubt, draw it out. The equation, a graph of a vertical line look like this, right? It's gonna be x equal or y equal. X. Yeah, I know it's x. Vertical, I know when we talk about vertical, like, oh, it's y axis is gonna be y. But no, it's x equals some number. There's no y in it. Just remember if it touches x, then x equal. So I'm just gonna say x equal a. A could be any number on the number line. What is the equation of a horizontal line? Y equal b. And last but not least, the general form. It looked like this: ax plus by plus c equals 0, where ABCs are just a real number. Let's do number 1 and we call it a day. Find an equation of a line that passes through the point 3, -1 and had a slope of 5. So when I ask you to find an equation of a line, you need 3 things. Can someone name one of them? Need, well, first of all, we need, yes, very good. We need slope, right? We need a slope. We need m. What else? A point, right? We need a point. They give me a point. to start with. And then the third thing you need is to remember the formula, the y minus y1 equal m times x minus x1 to plug it in. Do I have a point? Yes, I have a slope. Yeah, the slope is 5. A point is 3, negative 1. All I have to do is just plug it in. Y minus y1 is what? Negative 1, right? Equal 5 times x minus 3. Y plus 1 equal 5x minus 15. Subtract 1 both sides. You have y, do like this. Y equal 5x minus 16. Not too bad, right? Okay, then in 661 or high school, whatnot. So this is 1.1, 2.1, 2.2, relatively easy. Okay, we stop it right here. We'll continue next time. Have a good one, and I'll see you Friday.
I saw the video 16 times 4
So you divide what?
divide.
Yeah, that's good.